All right, let's talk EKS upgrades. If you're running Kubernetes on AWS, you know that keeping your cluster current isn't just a good idea, it's absolutely critical. Today, we're going to run through the gauntlet of a multi-version upgrade, a journey that has some very specific rules you need to follow to a T.
So, you're staring at your cluster. It's sitting there on version 1.31, and the big goal is to get it all the way up to 1.34. Seems simple enough, right? But this isn't just one big leap. It's a journey with a very specific, and I mean specific, set of rules. And when I say rules, I'm not kidding. In the entire world of EKS upgrades, there is one fundamental law that dictates this whole process. And trust me, breaking it is just not an option. And that brings us right to the heart of the challenge, the mandatory path. This isn't one of those choose-your-own-adventure deals. Nope, the path is already set for us, and we have to walk it. Here it is, the unbreakable rule. Amazon EKS does not support skipping versions, period. You have to upgrade sequentially, one version at a time. That means you're going from 1.31 to 1.32. Then, once that's done, you go from 1.32 to 1.33. And finally, you make the last jump to 1.34. Each of these is its own separate, mandatory mission. Now here's where it gets interesting. A clock starts ticking. The moment you upgrade your EKS control plane to a new version, Amazon gives you a 30-day window. And within those 30 days, you have to get your worker nodes upgraded to match. This isn't just some arbitrary deadline, you know? It's to prevent what's called API skew, which is a fancy way of saying your control plane and nodes start speaking different languages. That can lead to all sorts of weird behavior and security holes. Okay, so how do we actually tackle this, one version at a time? Well, it all boils down to a pretty simple 3-part battle plan that you're just going to repeat for every single version hop. For each and every jump, 1.31 to 32, 32 to 33, and so on, you're going to follow this exact sequence. First, you upgrade the brains of the whole operation, the control plane. Second, you update the essential managed add-ons, things like core DNS and kube-proxy. And third, you upgrade the data plane. That's your worker nodes where all your applications actually live. You just rinse and repeat that loop 3 times and boom, you're at 1.34. Of course, it's not quite that simple. Each version comes with its own little package of changes. So let's do a quick intel briefing on the key things you really need to be watching out for at each stop along the way. So jumping to 1.32, the big headline is API removals, specifically the V1 Beta 2 and V1 Beta 3 versions of the Flow Control API are gone. That means you've got to check your manifests, your controllers, anything that talks to the API to make sure you're not calling those old versions. On the plus side, in-place pod vertical scaling is now on by default, which is pretty cool for resource allocation. Next up, 1.33. And yeah, the cleanup continues. The old deprecated pod eviction timeout flag for the kubelet is officially gone, so you'll need to scrub that from any of your configurations. Same story for the V1 Beta 1 version of the lease API. It's gone too. Really, this is all about making sure your own code and configs are keeping up with Kubernetes itself. And finally, at our destination 1.34, we get some really nice stability improvements. CSI volume expansion is now a generally available feature, which is fantastic news for anyone managing storage. Plus, Pod Security Admission gets some major enhancements, which really helps beef up your cluster's security right out of the box. Okay, so no battle plan is ever complete without contingency plans, right? What happens if something goes sideways? Let's talk about how to handle those uh-oh moments. Now, this is probably the single most important warning in this entire guide, so listen up. EKS control plane upgrades cannot be rolled back. I'm going to say it again. Once you hit that upgrade button and it succeeds, there is no going back. You can't just undo it. This is exactly why all the prep work is so important. So how do we deal with that risk? First, and this is totally non-negotiable, you have to run the entire process in a test environment first. No excuses. Second, after you upgrade the control plane in production, just wait. Leave your nodes on the old version for a little while. Make sure everything is stable before you commit the nodes. And for the super cautious, a blue/green strategy is the safest bet. You just build a brand new, fully upgraded cluster on the side and then migrate your traffic over. You're probably going to hit a few common bumps. Is an upgrade just seems stuck? Honestly, sometimes you just need to wait a bit longer. Look for a resource in use exception error. If your nodes won't go into a ready state, it is almost always a networking or an IAM permissions problem. Pods failing to evict? That's your cue to check your pod disruption budgets. And if you start seeing API errors, well, that's what we talked about. Time to update your YAML files.
All right, let's pull all of this together into a pro-level playbook. If you follow these best practices, your upgrade process is going to be smooth, it's going to be predictable, and it's going to be successful. First up, let's talk time. For each version jump, you can figure about 20 minutes for the control plane itself and maybe 15 for a node group. But look, the most critical part is the validation and testing, and that can easily take an hour, maybe more. So for the whole journey from 1.31 to 1.34, you should really budget at least 2 solid hours of focused work. And that's not even counting all your prep time. When it comes to upgrading your actual nodes, you've really got 2 main paths. A rolling update is the faster, simpler way. It just replaces nodes one by one inside the group that's already there. A blue/green deployment is the safer route. You build a completely new set of nodes, carefully shift your traffic over, and only then do you tear down the old ones. It's basically zero downtime, but it definitely takes more setup. And here it is, your final pre-flight checklist. Before you even think about touching production, make sure every single one of these boxes is checked. You've backed everything up. You've gone through the API changes for 132, 133, and 134. You've done a full practice run in a test environment. Your team knows about the maintenance window, and you have a crystal clear plan to roll back your applications and workloads if something goes wrong. So you made it. You navigated the gauntlet. Your cluster is running on the latest version. Awesome. But the work of a great engineer is never really done. The upgrade is complete, sure, but is your cluster now actually taking full advantage of all the new features? Is it fully optimized for performance, for security, for cost? Well, that's the next adventure, isn't it?